Hello everyone, in this video I'm going to show you how you can use LTSpice to simulate basic digital logic gates and combinational circuits. So first you need to have an LTSpice workspace for doing the simulations. You can go to this particular link, GitHub link, where I have hosted the LTSpice source file. So you can download this GitHub as a zip file, and inside the zip file, go to code examples and you'll see LTSpice basic gates. I have already downloaded this, so it is in the downloads folder. So you can go to basic gates here and you need to install LTSpice. So you can search for LTSpice installation and you'll get an LTSpice installed in your system. And once you have installed LTSpice, then you can open this particular folder. And what you see in this folders are schematics. So these are all the schematics that are available, and these are the LTSpice symbol files. So there are two kinds of files in this folder. So leave about the rest of the files. Those files are generated when you do the simulation. So there are two kinds of LTSpice files. One is called the schematic files, and another one is called the symbol files. So let us start with opening the test bench file. Say for instance, here we are using a test bench and let us open this test bench and file. So this is a test bench which is used for simulating a AND gate. So this is an AND gate, and how many terminals are there for the AND gate? There are about five terminals. One is for VDD, one is for VSS, two input terminals, and one output terminal. So there is a load capacitor connected to the output terminal, and voltage sources are connected to the input terminals A and B to apply logic 0 and logic high. Here logic high is applied by giving a 5-volt signal. The supply is given to 5 volt and there is a VSS which is connected to ground. Now here the simulation time, we are doing a transient simulation and the simulation time is defined as 1 millisecond. So what it means is that it will simulate the LTSpice will simulate this circuit for about 1 millisecond. Now, if you want to simulate it, click OK. Now, the inputs that are given are A equal to 5 volt and B equal to 0 volt. The output that you should get should be 0 volt. And what we are getting is around 24.6 nanovolt, which is very close to 0 volt. If you want to see the voltages in a better way, there is an option to place a dot of data label. What it means that it places operating point here. So 5 volt and 0 volt are the inputs, and the output is 24 nanovolt, which is 0 volt. Now, if you change the B to, you can change the voltage of the B to 5 volt, and you are expecting the AND gate to give an output of 5 volt, which is what is happening here. So this is how you see. This is how you simulate an AND gate in LTSpice. And this AND gate is basically created using a combination of a NAND gate and a NOT gate. So this schematic is defined inside the AND schematic file. So if you look at the AND schematic file, you can see that the AND gate is created using a NAND gate and a NOT gate. And if you want to look into the NAND gate, it is designed using PMOS and NMOS. The same with the NOT gate. The NOT gate is also designed with the PMOS and NMOS. Okay, so that's how an AND gate is created. Let us also look at the test bench or. Okay, so this is a test bench or. Uh, Let us try to simulate this in an OR gate. When the inputs are 0, let us place operating point. When the inputs are 0, when the inputs are 0, the output is also 0. So 24 nanovolt is very close to 0. When at least one of the input is 5 volt, the output becomes 5 volt. Okay, so this is how an OR gate behaves. An OR gate is created using a NOR gate and a NOT gate, and a NOR gate is created using PMOS and NMOS, and the NOT gate is created using PMOS and NMOS. This NOT gate is basically the NOT gate that you find in the basic gate circuit. Okay, so let us say you want to design a you want to replace this. Okay, so what you want to do is you don't want to simulate an you don't want to simulate this Okay, so let me see. You don't want to simulate this. Uh, you don't want to. You want to replace this OR gate with. You want to simulate this OR gate with a different gate. So let us say that you want to simulate a NOT gate. So what you should do is you have to place a symbol. So how do you place a symbol? You have to go to you have to go to the component, and instead of show all, we have to go to the schematic directory. So this corresponds to the directory from where we have opened this particular file. And then let us take the NOT gate as an example and place it here. So the NOT gate has only NOT gate has only one input and one output. So let us do that connection. So you need to have a wire connection connecting the input and the output. So this NOT gate is something that is defined inside the directory. So this is a NOT gate that we have used. This is a NOT gate that is being placed here. Okay, so let us save this in the same folder as a test bench uh, temp file. Okay, so we are going to simulate this. Let us see what happens. So let us close this. Let us do the simulation again. Okay, so the input is 5 volt. When you simulate it, the output has to be 0 volt, which is what you are seeing here, which is 24 nanovolt. So if you want, you can place an operating point here and place an operating point here. So it is 24 nanovolt. If I change this to 0 volt and then do the simulation, here it becomes 0 volt, here it becomes 5 volt. So that is how you simulate logic gates, basic logic gates in LTSpice. And let us say you want to simulate a combinational circuit. So let us say, what is a combinational circuit you want to create? Let us say that for time being, what you want to do is, let us say for time being, what you want to do is, let us say that you want to have a two NOT gates in series. Okay, so you do Control C and do Control V. You get one more NOT gate. You can press delete to delete these connections. Okay, so you complete the wiring. So VDD has to be connected to the VDD here. The ground has to be connected here. Now press Ctrl C, copy this somewhere here, and press delete and delete this part. Okay. So this is a combinational circuit which has been created using two NOT gates. And these NOT gates, let us say, will instead of copying it, let us place a NOT gate from the NOT gate again. So what you can do is you can go to the components here, uh, ensure that you select the schematic directory as a basic gates, click on the NOT gate, and then say place. Okay, so these are the two NOT gates which are placed in series. And let us see what will happen when we do the simulation. So if you press here, this is 0 volt, this becomes 5 volt, and this becomes 0 volt, which is what is happening here. This is 24 nanovolt, which is very close to 0. If I change this to 5 volt, and when you do the simulation, what you get is 5 volt. Uh, so in short, the folder here has basic gates which are already defined. We have the AND gate, NAND gate, NOR gate, and NOT gate, and OR gate. If you want to test these gates, you can use these test benches which has been created. If you want to create a combinational circuit, what you can do is you can open any of this test bench and save it, and delete the components in the test bench, and you can add the logic gates one by one from this directory and then connect in the way that you want, and you can do the simulation. Let me now show you how you can simulate a generic combinational circuit. Let us open the schematic. Go to open and select the schematic test bench func. So this is a schematic that has been created which can actually perform simulation of a three input combinational circuit with just with one output. So this combination circuit is named as G of ABC, and you are applying voltages to the terminals ABC, and a load is connected to the terminal Y, which is a capacitive load. And we have already created the schematic for this particular combinational circuit using AND gates, OR gates, and NOT gates. These gates are placed from the same directory for this test bench is saved. Test bench schematic is being saved, and you can rearrange these gates. You can delete the gate, add the gate, connect them in different ways to realize a different combinational circuit. The restriction is that it should have three inputs and one output, because the symbol that we have defined here, or the symbol that we have used here, is a symbol for a combinational circuit with three inputs and one output. Okay, let us see how you can simulate it. You can click on the simulate button, and what you can do is let us close all other schematic. Let us close all other schematic and run the simulation again. Okay, so when the input is 5 volts, A equal to 5 volt, B equal to 5 volt, and C is equal to 5 volt, the output you are getting it as 5 volt. And the reason why we are getting an output of 5 volt is basically it dependent on how the circuit G of ABC is being wired inside the combination circuit. So if you want, you can modify this connections and then see how the output changes when you simulate the test bench from test bench when you simulate the test bench. Let us say for time, let us say what we want to do is we want to simulate a generic combination circuit with four inputs instead of three inputs. So what is the step that you need to do? So let us do one thing. Let us use this as the template and save this, and let us make it as a function G with uh, four inputs. Okay, so this is a test bench with a function G with four inputs. So let us close the rest of the thing. So we need to have four inputs. So this symbol only has three inputs. So let us do one thing. Let us open this particular symbol, which is also present in the basic gates directory. You have to change it to symbols, and you have to select the symbol which is corresponding to fun underscore g, which is function underscore g. Click on open. Yeah, so this is how the symbol is defined. Let us do one thing. Let us save this symbol as fun g underscore four inputs. Okay. So what we want is four inputs. So do Control C and do Control C and then copy paste this to copy paste the terminal here and make it as D. Okay, so that is what we have done here. For time being, we will leave about this alignment part. Let it be like this. We have just changed the terminal. We have just added one more terminal here. Now you save this file and come back to the test bench. Delete it. Press delete and delete this symbol. Now go to the components here and place the component corresponding to function G four inputs. Okay, so it says that it is not available here, and that is because we have not created a component for function G four inputs. So you come out here and open the function g component and save this as function g for inputs, and it should be a schematic file, so it should have an extension of a c, or just leave it, it will save it in the extension asc. So it has a b c and one more input which is d. So what we can do here is mm, what we can do here is we need to have one more input. So let us do one thing, do control c and change this to d, click ok, and let us do one thing, let us delete this and right click, edit, uh, click on move, and then move this over here. We will have one more OR gate, so control C it here, and you connect it. Mm, so you have to complete the connection, and you delete this, you complete the connection somewhere here. Okay, so it's a some combinational circuit with four inputs and one output y. Now you save this as function g underscore four inputs, function g underscore four inputs. It has a simple file as well. Now let us open the test bench function g four inputs, and you delete the existing combinational circuit simple. Go to the components, select schematic basic gates. You see the function g4 inputs here. So place it. For time being, let us do one thing. Let us connect the D terminal also to D terminal to the ground, and let us run the simulation. So let us see what happens when you run the simulation. Yeah, so when the inputs are high, the output is 5 volt. So if you want to verify why this is happening, well, you have to go and look at the combinational circuit which is there inside GABC. Actually, it is not GABC now, it is GABCD now. So let us make that change also. So come to function G4 inputs, come to function G4 inputs, and right click on this and make it GABCD. Okay, so now you save this. Now you open the function test bench function g4 inputs. What you can do is you can delete this and place that component again. Okay, sorry, let us do one thing, let us close this, and now again open the function for inputs test bench. You place a component. Okay, so you have the component as GABCD. Now let us do the simulation and see whether it is working properly or not. Yeah, so it is simulating properly, and the reason why you are getting an output, if you want to know the output, you have to look into this combinational circuit, figure out the expression of y as a function of a, b, c, and d, and then we can verify whether the output is. Then we'll be able to predict the output as a function of its input. Okay, now let me now show you how you can clean up this symbol. So right now we have the symbol for a generic combinational circuit with four inputs and one output. But as you can see, the alignment of the alignment of the fourth terminal is not uh, uh, proper, meaning that C and D terminals are not equally spaced. Let us see how to fix this. So you can close this. Let us for time being save it. Uh, close this, and then open the basic gates. Now let us open the simple file for function G4 inputs. So what you see is a simple file like that. Zoom in and zoom out using the scroll bar of the mouse. The next what you can do is you can select on the stretch mode and select the section you want to stretch and then bring the mouse downwards. Now the C and D spacing is same as B and C spacing. What we want is we want to make this square also proper. So this looks more or less like a symmetric shape. You want the Y to be at the center. So let us make the Y to be at the center. Now you save the simple file. This is how you modify the simple file. Again, you can click on the stretch and can make this text appear at the center. Okay. Now you save the simple file. You close this. Now you open the test bench function G4 inputs. Okay, so this is already modified. Zoom out. What you can do is you can use the move mode so that you can move this uh, simulation command a little bit. Then you can use this. Then you can use the stretch mode and stretch this a bit. Okay, so you can delete this section, delete this part. Okay, now you can complete the wiring. So you go to the wire and let us say D terminal has to be connected to the ground. The Y has to be connected to the load, which is a capacitor here. Instead of connecting to the ground, let us connect it to a voltage source. So press Ctrl C and click on this so that you can paste it here. Click on the wire button, complete this, and complete this connection. So delete this section. Yeah, now the a generic combinational circuit. This is a test bench for simulating a generic combinational circuit with four inputs and one output. So for timing, let us keep A, B, C as 5 volt and this also as 5 volt, and let's see what happens when you simulate it. Okay, so when you simulate it, the output is also 5 volt. So if you want to understand why the output is 5 volt, you'll have to go into this combination circuit and evaluate the expression, evaluate the equation of y as a function of a, b, c, and d. Okay, so basically, you can use this method to create a test bench to simulate a combination circuit with five inputs, six input. If you want to create a combination, simulate a combination circuit with multiple outputs, that is also possible. Okay, thank you.